Okay, let's jump right into it. Have you ever walked past one of those massive, immovable concrete buildings and thought, how on earth do we update this for the modern era without taking a literal wrecking ball to it? Well, as we're going to see in this explainer, the answer actually doesn't lie in physical construction at all. It's all about smart software, specifically a really brilliant framework known as the INTELLI-LITE solution. Take a look at the subject of our spatial mystery today. This is the Perpustakaan Tan Abdul Razak, or PTAR, an academic library in Malaysia. Notice that superimposing rigid exterior? Those are fixed concrete fins. And, they're a defining feature of this kind of legacy brutalist architecture. Now, on one hand, these fins are fantastic passive buffers against that intense tropical heat. But on the other hand, well, this unyielding facade creates a massive energy-draining problem once you step inside.
So, let's look at Section 1, the concrete library dilemma.
Moving from the outside in, we immediately hit this central conflict between, unyielding concrete and the very basic human need for natural light. You can see how those same protective fins outside severely restrict diffuse daylight from actually penetrating the workspace. And think about it. Students doing deep library work desperately need visually ergonomic environments so they don't strain their eyes. But this architectural setup, it literally forces them into the shadows. To really wrap our heads around the scale of this problem, check out this staggering number. The continuous structural depth of this building's floor plan is an immense 41,100 millimeters. That's over 41 meters of continuous internal space. Natural light from the perimeter just simply cannot reach across a floor plan that deep, especially, when it's being blocked by giant concrete structures right at the window line. The core issue here is that this incredibly deep floor plan creates a massive and sharp daylight drop-off. And to compensate for this chronic underillumination, facility managers are basically forced into a corner. They end up having to constantly run manual, non-dimmable artificial lights at 100% capacity all day long. They're totally disregarding whatever peripheral natural light is actually available near the windows, which, as you can imagine, wastes incredible amounts of energy. Moving right along to Section 2. The 3,000 millimeter threshold. Now, the researchers looking into this didn't just guess how the light was behaving, they actually measured it. By running empirical field audits with lux meters and digital twin simulations, they found this highly constrained sweet spot. Optimal useful daylight illumination, which is basically that ideal reading light range of 300 to 2,000 lux, drops completely dead past an invisible boundary exactly 3,000 millimeters from the window. Literally, right past that line, the natural light just plummets. This right here brilliantly illustrates the intense contrast at the heart of the building's flaw. On one hand, you have this tiny, narrow perimeter zone of just 3,000 millimeters where natural light is perfectly self-sufficient. But then you have this massive, dim core stretching all the way to that 41,100 millimeter mark that desperately needs active artificial illumination. The contrast is just immense. All right, on to Section 3. 3 tiers of smart lighting. So, instead of bringing in bulldozers to smash the concrete, researchers asked, how can we use digitalization to solve a purely physical problem? And the answer is INTELLI-LITE. It's this ingenious conceptual framework that takes that rapid daylight decay curve we just talked about and converts it directly into software logic. By plugging this into the existing building management systems, they entirely upgrade the building's operations without a single expensive structural renovation. Pretty clever, right? The whole journey is incredibly logical. Physical field and simulation data, the lux meters and software, lead directly to the discovery of that strict 3,000 millimeter limit. That physical data then feeds right into the INTELLI-LITE framework, creating a distance-responsive software integration model that dynamically controls the LED lights. Let's actually walk step by step away from the window to see exactly how this plays out in practice. The framework establishes what they call a 3-tier spatial zoning matrix. It basically sections the building into 3 specific zones based entirely on how far the natural light naturally travels from the facade. Here's the automation logic actually in action. In Zone A, that perimeter from 0 to 3,000 millimeters, glare is naturally mitigated by the exterior fins and the light is optimal. So the software just deactivates the artificial lights completely. Done. Moving into Zone B, from 3,000 to 8,000 millimeters, natural light drops off. Here, the system actively injects supplemental dimmable LEDs to perfectly balance that sharp gradient. And finally, Zone C is the deep core beyond 8,000 millimeters. That zone relies purely on smart occupancy triggers, so the artificial grids only turn on when someone is actually using the space. And finally, Section 4, a low-cost energy solution. So, what's the final payoff for bypassing those expensive physical renovations and trusting this digital approach? Honestly, the outcome is phenomenal. Implementing this simple three-tier logic into the management system yields a massive projected 35 to 40% reduction in lighting energy overheads. And crucially, it pulls this off while establishing a totally stable, ergonomically sound visual environment for the students. It is literally a win-win. I want to leave you with this somewhat provocative thought. If smart software can teach a rigid, legacy brutalist library how to essentially breathe with natural light, adapting to the sun rather than fighting it, what other old buildings can we save from the wrecking ball using just data? I mean, our built environment is absolutely full of these concrete giants, and perhaps the key to making them sustainable isn't rebuilding them from scratch, but simply giving them a smart, invisible digital nervous system. It entirely shifts how we view the future of retrofitting, doesn't it?